Consider the quadratic function f of x is equal to 2x squared minus 13x plus 15. So we have to state an appropriate window setting for displaying the graph of the function on a graphing calculator. So by this what we mean is sometimes when you look at your calculator and the graph, you're not going to see some of the most important parts because the parabola might be in a different spot, or maybe it's too big or something like that, so it's hard to see what the parabola looks like. So sometimes you're going to have to adjust the window settings so you can see it properly. So that's what we're going to do. So first off, what you're going to do is you're going to enter in your quadratic function using the y equals feature, and you're going to input it into y1. So this is what it looks like so far. This isn't too bad. You can see the vertex, which is the minimum point of this parabola. You can't really see the y-intercept, not to mention there's a whole lot of wasted space on the left-hand side of the screen, so we're going to adjust that a little bit. So when you're dealing with calculator window settings, helpful to keep a couple of things in mind. Of course, that is your y-axis, and this is your x-axis. Okay, up here is going to be your y maximum, and down here is going to be your y minimum. You can adjust those. Right now, if you count the little ticks on the screen, it goes up to 10 and goes down to -10. Same thing, this here is going to be your x minimum, and this is going to be your x maximum over here. And it goes from +10 to -10. Each one of these tick marks right now is equal to 1 on your calculator, but we can adjust those as well. You can make the tick marks equal to 2, 4, whatever number you like. Okay, so keep this in mind. We probably don't need all that much on the left-hand side here. We probably delete that out. So you're going to adjust your x minimum, so probably it's going to be a bit smaller than the default -10. So again, these are your default settings. If you ever want to get these settings back, all you have to do is press zoom on your calculator and 6, and that will give you these default settings back, because your calculator actually saves the settings you used from the last one. So it's going to be zoom and 6, and they'll give you back these settings, and then you can readjust it as you see fit. So your settings may vary, but you notice here what I did was we didn't really need all that amount of space on the left-hand side. Remember the drawing I had earlier. We didn't really need a whole lot of stuff on the left-hand side, so we cut it out a bit, and so I made the minimum about -5. Okay, x maximum, I didn't really change that. It's still going to be about +10. Alright, the y minimum we didn't really change all that much, but we did affect the y maximum. In this case, we made it a bit bigger. Alright, this of course allows us to see where that parabola may cross the y-axis. Our scale, you notice we adjusted that a little bit. We put the scale as 5 in each case. Again, your coordinates might be something slightly different from this one. So this is what your graph is going to look like after you have changed the settings around a little bit. Now we can see the y-intercept. You can see the vertex quite nicely here, and of course you can see your x-intercepts. Looks pretty good. Not to mention we don't have a whole lot of wasted space on this graph as well. Okay, so in B we had to determine the coordinates of the vertex. The vertex is right here. There is a way you can do it on your calculator, and it's going to be second function trace, and what you want to do is you want to look for the minimum. If your parabola is pointing up like this, you're going to be looking for the minimum. If it is pointing down like this, your vertex is on the top, and that's going to be a maximum that you're looking for. So be careful about that. Remember, it's going to be second function trace. Once you've done that, what you have to do is you have to put boundaries. Okay, so it's going to ask you for left bound here. You can place your cursor to the left of the vertex, and then of course what you want to do is you hit enter. Then it'll ask you for the right bound. So move your cursor to the right of the vertex and you can hit enter. It doesn't have to be the same. There's no exact value here, just as long as it's right of the vertex. So you hit enter after you do that, it's going to give you something, it's just going to say guess, and it's going to give you a bunch of numbers. Don't worry about that, hit enter as well. And then what it's going to do is going to give you the vertex itself. So just a heads up too, when you work that one out, your x on your vertex might be something crazy like 3.2499999. You can just round that up to 3.25 in this case. Your y will be a little bit more exact, and that will give you a value of negative 6.125. Next up, we have to explain how to use the coordinates of a vertex to determine the equation of the axis of symmetry on the graph. Alright, so your vertex, as we've determined, is 3.25 and negative 6.125. Now, it is good to note that this is your x value of the coordinate, and this will be your y value. Now, the axis of symmetry, or the equation of the axis of symmetry, is equal to the x value of your vertex. So your axis, or your equation of the axis of symmetry is going to be x is equal 3.25. Next up, what we have to do is we have to determine the x and y intercepts of the graph. So remember, an x-intercept is going to have an x value of something, but the y is going to be 0. And for a y-intercept, you're going to have 0 for a value of x, but then you're going to have a y. Now, in order to find your y-intercept, that's probably the easiest one to do. What you want to do is you want to hit your trace button. You're going to get a value for wherever the cursor is placed right at the moment. Don't worry about that. All you need to do is hit 0, and you'll notice on the bottom of your screen it'll say x is equal to 0. That's what you want, because when x is 0, what's y going to be? Your calculator is going to figure that one out. All you have to do is hit enter. When you do that, you find out that your y-intercept is going to be 0 and 15. It's a bit trickier to find the x-intercepts, but they are of course right here where they cross the x-axis. What you're going to be using is second function trace, and you're going to be looking for a program called 0. It's number 2 in your menu. So it's going to be second function trace and then 2 for 0. So it's going to be a little bit like what you had before with the vertex, where you had a left bound and a right bound. In this case, you're going to be doing that twice because there are 2 x-intercepts here. There's one right here and one right here. Okay, so for your left bound, you want it kind of to the left, the furthest left on the screen right here for the first one. You want it basically above the x-axis. So that's your left bound. Once you've found a nice spot for that, hit enter. And then it's going to ask you for your right bound. So you want to go to the right of the 0, and if you think about that, that is going to be below as a result. So determine your right boundary and then hit enter. It's going to have a guess again. Don't worry about that. Just hit enter again. And when you've worked that one out, the first x-intercept is going to be about 1.5 and 0. Alright, and so what you're going to do after that is you're going to do that again. You're going to hit second function trace, and you're going to use that 0 program, that's number 2. And then it's first going to ask you for a left bound. So this is a little bit different right here. I like to think of it as a roller coaster. Okay, the roller coaster is going to go from left to right. Okay, so of course you want to stop the roller coaster for the first one above the x-axis and then below. But as it moves along, okay, it's going to go down and then up. Your left bound is going to be actually underneath the x-axis. So hit your left bound underneath the x-axis. That's furthest left on your screen. That's pretty close to 0. And then you're going to move the roller coaster up above the x-axis, and you're going to find a right bound somewhere above it. Okay, hit enter and hit enter again for that guess. And what you're going to find is you're going to have an x value, or an x-intercept value, of 5 and 0. So those are your 2 x-intercepts, and you've got your y-intercept. You can actually determine the y-intercept pretty easily just by looking at the quadratic function itself. Now remember, we were dealing with 2x squared minus 13x plus 15. The y-intercept is going to be this part right here. It's your c value, as you can see right here. So we have to use the x-intercepts to verify the equation of the axis of symmetry. Remember, that is this equation right here. So in order to do that, what you need to do is you got to take your two x-intercepts, you're going to add them together and divide by 2. Okay, so it's going to be 1.5 plus 5 all divided by 2, and so that's going to give you 6.5 divided by 2, which is going to be 3.25, which is exactly what we got in the previous equation. For f, what we need to do is state the minimum value of the function. That's related to your vertex. The minimum or the maximum, depending on the parabola, is your y value. In this case, your minimum value is going to be negative 6.125. The reason? Well, if you notice, the parabola doesn't exist anywhere below negative 6.125. And so next up, we have to state the domain and the range of the function. Domain is where the parabola exists along the x-axis, so be careful about that. If it helps anything, these parabolas will go on forever, which is why I'm drawing arrows at the ends of them. Even though the calculator doesn't show it, this parabola continues on forever and ever and ever, and it'll keep going. So in this case, what we can say about the domain, x does not have any boundaries here. It is just a member of the real numbers. So in that case, when we expand that out a bit, it's going to be x such that x is a member of the real numbers. When it comes to the range, that's how it exists along the y-axis. Now you notice, underneath here, this parabola doesn't exist at all. Okay, there seems to be a point where it starts. In that case, that's going to be your minimum. So it's directly related to your minimum here. What you can say is that y such that y is greater than or equal to negative 6.125, and y is a member of the real numbers as well.